Hey, I'm Mark Elendt, and I'm here to give a small talk about arrays. Actually, I'm here to give a talk about small arrays. So, if I can do this, what I'm going to start off with a little example of what one of the problems that we run into in rendering in computer graphics. So you've got this little floaty toy, and it moves from one place to another place over a frame. What you want to do is you want to render it with motion blur. And so if you have two segments, what you can do is you can get motion blur that looks like this. However, if the motion in between the frame is much more complicated, like this, you need to have a lot more segments of motion blur. And so you can end up with some beautiful motion blur that looks like this. So the problem is that in typical cases, you have just two segments where you're doing something very simple, but you want to be able to let the user have arbitrary numbers of segments. So one way of approaching this, here's a function called compute transforms, which takes an array of transforms in, and a function called fill motion times, which takes an array of times that it fills in. And one way to do this would be to put a fixed limit on the number of samples that you could have for motion blur. And this works, except that it doesn't necessarily capture what the user wants. The user may want a very complicated set of motion segments. This will capture most of the cases, but in the extreme case, the user may want more than 32 segments. So of course, what you have to do is you need to switch over to std vector of transforms and a std vector of times. And this works great, except for those two functions right there when you call the reserve to set the size of the array, because that calls malloc, and malloc's really expensive, like really, really expensive, like 20 nanoseconds or something like that, I heard. What I did was I went to Godbolt and I did this little test program that had a fixed array, and this is the code that was generated to generate samples for a fixed array. And when I changed the if-def so that it uses std vector, this is the assembler that's generated for that, so it's a lot more assembler. But what's hidden away here is all these calls to std vector to allocate memory and deallocate memory. So it's extremely much more expensive than a standard fixed array. So what we want to do is we want to use something like, well, in Houdini, we actually have, like in many large projects, we've written our own array class, our own vector class. So this is the standard sort of vector class that you've got. You've got a pushback method, and you've got the reserve method. And the reserve method, if you look there, does a new and copies over the memory. So that's sort of what the array class does. What we did was, what we want is we want to have a small buffer that's actually stored in the array optionally. So what we did was we did a subclassing of the array. Now, this allows us to have a small array class that's inherited from the array class that has that small buffer. And so if anyone out there is following this, because I'm speaking kind of fast, what you'll notice is that there's a big problem because the base class is going to do a delete on that memory. And so if we've got it pointing to the buffer that's in member data, that's going to be bad news, and we're going to get crashes all over that. So there are a couple ways to try to address this. And just to point out, we aren't kind of unique about this. There are lots of places that do this. std_string has the small string optimization. LLVM did this small array as a separate class. So they have an array class, and then they have the small array class. And what we like is the ability to swap between small arrays and arrays. So what we do is we rely on inheritance in C++. So if you've got a class foo that has the 3 pointers, and you've got bar which inherits off of foo that has the buffer, the size of foo is 24 bytes, the size of bar is 64 bytes. If you look at the memory layout, you'll see that the buffer actually follows after the end of the foo class, right? So we modify our base class array to have this method right at the bottom called isHeap. And what we do is we say, if the begin pointer points to the end of the array, then we know that we're pointing to the heap memory off of the, it's really nasty, isn't it? It's really gross, but it works. So if we're heap memory, we do the deletion. If we're not heap memory, we don't bother deleting because we know we're pointing at that stack buffer. So this is the original code, which has arrays now. And then to switch it over to small array, if you watch that third line or fourth line, that's all we have to do. And it switches over to small arrays, and it's like insanely much faster. And that's it. Thank you.